Welcome to the Exactpro Systems YouTube channel. Here you can catch up on the latest technology updates in software testing and development for the financial industry. These include the applications of AI and machine learning, DLT, cloud computing, and many other technologies and solutions. You can find the recordings of our latest conferences featuring top-level speakers from global market infrastructures, world's leading banks, and technology vendors. You can watch the Exactpro experts sharing their insights with the fintech community at events all around the world, and with our subscribers in the regular Exactpro Talks segment. If you're interested in the Exactpro test tools released to open source, you'll find a list of tutorials here as well. We also put a new spin on some of the popular shows that we bet you've never thought were about software testing. This channel is for cheap technology, information and compliance professionals, product owners, and software quality assurance and development specialists of all levels. Subscribe to our channel, hit the bell button to stay up to date on all the videos, and visit our website exactpro.com if you want to learn more about us.
Hello everyone, I'm Andrei. I'm running advanced analytics and machine learning practices for Exactpro. We're starting our seminar. Today's session is an open one, and we'll talk about financial fraud, fraud detection, fraud prevention. Why fraud? As Exactpro, our ultimate goal is end-to-end reliability of financial systems. And we're not only concerned about how the systems work as they are, but also what people can do with them. And more and more scammers go online today, and they use sophisticated methods to bring insecurity by their actions. We're all facing scam with credit cards in our regular life. And today we will talk about machine learning approaches, how they can help detect scam, detect financial fraud. And ultimately, this can help us make our systems more reliable for our customers. Today, I welcome Dmitry Petukhov, who is consultant in machine learning, and he's got deep experience in financial fraud prevention. He's holding a Microsoft Most Valuable Professional credential. So, Dmitry, the stage is yours.
Thank you, Andrei. Hello, everyone. Thank you for joining this session. My name is Dmitry Petukhov, and as Andrei mentioned, I'm a consultant on machine learning technologies, cloud solution architect, Microsoft Most Valuable Professional in AI award category. For the next half hour, we will talk about financial fraud detection. I will make a separate emphasis on the use of intellectual or artificial intelligence methods for fraud prevention. This is the introduction lecture, and I try to minimize usage of special terms, but nevertheless, you will need to general understanding of the financial domain and machine learning. Let's start it. Okay. Why is so important? And I hope so interesting for you. First of all, because hackers are very inventive guys, and they are always inventive something new. At the beginning, they try to steal money from wealthy clients. It was quite large amount of money. Something about thousands of dollars per one victim, but it was quickly scalable. With the evolution of online banking, it has become faster to rob a lot of cardholders by withdraw from their cards less than $1, and it was a massive bank customers attacks. Remote communication was evolving and got popularity for financial operation inside and outside private companies, and it was time to hack companies and withdraw from their accounts thousands and thousands of dollars. But it's not all story. I suppose that 10 years ago was developed specialized banking malware and attack on commercial banks was started. And they were hackers were attacked successfully. And peak, but not the end of that story was in 2016. It was attack on Central Bank of Bangladesh. Using SWIFT networks, hackers attempt to transfer $1 billion and $81 million was stolen successfully. As you understand, nowadays bad guys try to hack all. And they have many methods for this, special anonymized networks, tons of malicious software. Among them, there are specialized banking malware, special social engineering methods, and even special class of malware called TrickBot. TrickBot is targeted to search and collect banking accounts and credentials. Moreover, don't forget that financial fraud is broader than banking fraud. Manipulation of assets price, financial statement fraud, ICO scam, it's also financial fraud. Sometimes financial market fraud has more losses and social consequences. Okay, let's try to stop bad guys. The first challenge, we have several challenges in this field, and the first challenge for payment fraud, we have large number of interacting parties. Cardholder, merchant, one bank for processing payment, another bank which issued card networks such as Visa, MasterCard. In addition, there are payment processing providers, digital wallets like Apple Pay or Google Pay. And you see simplified payment diagram. In real life, it's more complex. There are a bunch of such diagrams for different payment types, for ATM payment, for interbank transfers, for fraud dispute process. But it's not all bad news. Hackers in this diagram is not only outside. Very often he or her is inside. We know merchant fraud. It's a situation when fraudsters is merchant. We know customer or cardholder fraud, or when cardholder is fraudster. Banks insider, financial market insiders. The challenge number 2, there are too many interaction points. About 10 years ago, we have credit cards and box office in bank only. Now we have NFC, digital banks, digital wallets, QR codes, biometric identifications, cryptocurrencies, anonymous payment for buying pizza. Why not? More company brand is almost completely in web now. And attack to brand using social networks, fake news, has serious consequences. In 2015, there were multiple information attacks via SMS and messengers, and as a result, one big bank lost deposits for total amount 1 billion rubles for 2 weeks. Challenge number 3. It is data. It is data that we have as input for our anti-fraud model. There are a lot of restrictions. Main of them, we have huge amount of data, billions records for medium bank, or 10 billions records for medium broker, or market stock. But only small dozens of that data are marked. Furthermore, the data is incompleteness. Often we don't see all fraud cases. Some fraud cases were missed. Some real fraud cases we have without compliance, customer complaints, and vice versa. Some of legitimate payments or legitimate trades we marked as fraud, but customer or trader didn't complain about this. All these cases are type 1 and type 2 errors. And some of these cases we don't have in our data. Sounds impossible, but it's real life. A few words about label in data. In real life, there are no black or white colors only. Hackers and robbing goods only. In real life, we see huge amount of suspicious payments or operations or financial operations. For example, small boy paid goods in game using father's card. It's type of fraud called family fraud. Of course, a boy doesn't ask about it his father. Nevertheless, the fraud is multicolor, and this color constantly change, disappear one and appear another. For this reason, often we have irrelevant fraud markup of our data. Often we have all data set that almost useless for real life. And last but not least, we must remember about private life of our customers, about ethics sites, gathering data, and about regulatory requirements. Okay, now we all know about challenges and potential bottlenecks in our data, and I think it's time to create an anti-fraud system. Anti-fraud system is very complex, complex system, and core of such system, of course, is anti-fraud model. There are two main approaches to create such type of models. First one is rule-based anti-fraud. For this, you need multiple black or white list, cards, IP addresses, devices, fingerprints, banks, organization for payment frauds. For market fraud, you need to black, white list companies, banks, some brokers, or IP addresses or IP subsets. For insurance fraud cases, you need to black, white list hospitals, concrete persons, maybe some diseases. In additional to black white lists, you should to create some statistical based features such as count of different devices which paid by that card for last 24 hours, for example. And then you need security analytics. a lot of security analytics who will be analyzed protected domain, payment, trading, insurance. Second approach is a machine learning based approach, machine learning based anti-fraud, and here it will be more interesting, I hope, for me exactly. There are two directions. First direction, there are three directions, of course. First direction is fraud detection. We use data sets with labels and train model that distinguish fraud and legitimate payments or operations. For this purpose, we use supervised learning algorithms. In second direction, which second direction is anomaly detection. And now we use unmarked dataset or dataset without fraud labels. And there are two goals potentially achieved. First one is a training models that can separate transaction or customers or merchant or equities or crypto tokens separate on different clusters. Second goal is a training model that can reconstruct event or process characteristics. Later, I will tell you details. If reconstruct error is big, then probably it is anomaly. If it is anomaly, we should investigate reason. Simple. Okay. Let's and the third directions based on semi-supervised learning. It's some hybrids of previous two directions, supervised learning and unsupervised learning algorithms. Okay. Okay, let's suppose that you want to try supervised learning algorithm for fraud detection. Good news. It is the right idea. Bad news. Prepare to spend about 95% of time to collect and processing data. And my advice. Do not use accuracy metrics to evaluate model quality. You should use recall, precision, F1 score, or AUC under precision recall curve for robust model estimation. Much better, or ideally, if you write your own valuation metrics based on financial losses. Now about state of art for detect fraud. As you see on picture, for good and very good data sets, you can hope that model detect about 80% of all transactions, or all fraud transactions. It is sensitive metrics, sensitivity metric on picture. And also can see that number of legitimate transactions that marked as good are close to 100%. And it is a specificity metric on picture. Tree-based algorithms are usually most useful for fraud prevention due to dataset characteristics. As I mentioned, data have a lot of outliers, not Gaussian distribution, noise and missed values, hundreds or thousands of levels for categorical features such as mobile application ID, merchant ID, bank ID, currency code, or whatever. For the same reason, neural networks is out of scope. But don't upset if you find a deep learning very soon. you can see all the power of deep neural networks. And let's change main task from predict route to detect anomalies. And also change a family of algorithm from supervised learning to unsupervised learning. Now we don't need labels in data and can use so much data as we have. It's very ambitious claim, but but okay. And it is good news. Bad news, we need to interpretation model outputs. Let's tell more details what I mean. Start from clustering methods. Clustering methods divide samples in dataset by several clusters. And additional task for analytic is investigate which cluster, what does it mean in real life, in domain. And slightly different or drastically maybe different approach have neural networks methods. Some of the neural network methods, like autoencoder neural network, create some. I missed clustering methods. You see, I missed some important detail. Result of all clustering methods you see on a picture, and there is real research when we clustering images using transfer learning. It's transfer learning and some pre-trained convolutional network. Okay, the result is next. Is the following. We have the following result. We successfully separated cats photo from dogs photo, and of course our cluster algorithm hasn't any bias about animals and of course about dogs and cats. As a result, we have two clusters with different animals which imagine or which we have on photo. And as I already said, we have slightly different approach in neural networks algorithm, and I want to discuss a little more details about autoencoder neural network architecture, and on input of the type of neural network autoencoder, we have some data, and output of our neural network. It is almost the same data. It's a result of reconstruction our input. In the middle of that neural network, we have some latent representation. You see on pictures that is some draw by hand cat, but it is I think good consideration, intuitive consideration. And representation level trained, and after it trained, it's helping decoder layer reconstruct events, processes, or images with cat. If you pass to input cat and model has output also cat, it means that it is good cat or maybe real cat. But if output returns dog, in other words, model reconstruction error is high, it means probably it is hacker cat or bad cat. Deep, it's what I want to say about autoencoder like architectures, about deep belief network and generative adversarial network, or GAN, or shortly GAN. They are both generative neural networks. One of them, deep belief network, based on restricted Boltzmann machine. Restricted Boltzmann machine, it's some type of stochastic neural network. And the second neural network, general adversarial networks, based on two neural networks. One of them, it's discriminant neural networks, and another generative or generate new images and new operation, generative neural networks. And there are some discriminant neural networks distinguish cases which generated by generative neural networks and real cases. For anomaly detection, it is some research papers which use one class GAN for solve anomaly detection problems. I think that all about briefly, it's all about methods which we can use for anomaly detection. It's cluster methods. It's some anomaly detection classic method not based on neural network architecture, and there are bunch of research related with different neural networks architecture that solve anomaly detection problem and in fraud domain also. Thanks a lot for your attention. I hope that this modest no, it's not. It's not all. Of course, I need to say something, like conclusion, and the conclusion is the following. I want to sum it up. I think previous slide and maybe add some new ideas. Financial fraud prevention is a big and important for business and society field of research. Financial fraud prevention case combines three domains together. It's financial domain, it is cybersecurity, and it is data science. The diversity of participants and their economic interest, the low quality and high sensitivity of financial data are the main challenges. and to create high-quality solutions, researchers, software engineers, security analytics actively use the capacity of math and machine learning. The most promising approaches are based on supervised and unsupervised learning algorithms. Using them, we can solve problem of fraud prediction and anomaly detection with ability to process large amount of data and which to process large amount of data in near real-time mode. That it is very important things. And the last but not least, the quality of best anti-fraud models is moderate, but it's not ideal, and I think it's chance for all, for researchers, for companies, for enthusiasts. And now I can say thank you a lot. Thanks a lot for your attention. I hope that this modest introduction in fraud detection will inspire you to your own research or project in this field.
Thank you, Dmitry.
Feel free for asking me any question.
Actually, we're not yet finished. As I have several questions really, and
okay. Of course.
Guys that are watching us, please also feel free to post your questions to YouTube, and I will read them, and so that Dmitry will be able to answer them. So now is the question time, and I will start if you please. So I'm interested in how is the market organized today? You said that the model quality is quite moderate as of now. So the world is running on rule-based systems, right?
A lot of proprietary system or closed system in banks. It is a rule-based system, and as opposite, there are a lot of startups in Silicon Valley and maybe in another country who use machine learning approaches, so machine learning capabilities for tracking different types of frauds, and it is software as a service. For Russia, it's not very popular because there is a lot of legal restriction, as you know, related with transfer your private data via board.
So you cannot use software as a service vendor if you are residing in Russia and the vendor is outside. So most of the banks then apply some kind of machine learning or develop something on their own, right? Here in Russia.
Not most. I think Tinkoff, Sberbank, Alpha Bank, and I need to think deeply for remember yet another. It's not. We have about, I think, 200 banks, about 30 banks. It is retail banks, but machine learning approaches we have only in few banks.
Okay, but if you don't take Russia, but worldwide, are they still developing anti-fraud approaches in their inside? I mean, each bank for its own customers, or are there any well-developed vendors that provide some platforms for this purpose?
It changes from country to country. Let me get more details. not get. Then one important thing, it's about insurance of payments or payment operations. In some country like like USA, there is a lot of companies that do insurance, and banks, issuer banks, can feel free, maybe, but in that country, payment service provider have very interesting or very sophisticated machine learning algorithms for detect fraud. I think in some countries in Europe, we see machine learning algorithm for issue ban. As I mentioned, there are a lot of participants, and in other countries, in different countries, they have different IT infrastructure, and briefly, it depends. In Russia, we have good IT level in our banks.
Okay, we've got a couple of questions from the field. One from Tatiana. I guess there should be a difference in work of algorithms for cat-dog and yes/no decision. So, is there any difference between when you distinguish between cat and dog, and when you classify yes and no for fraud?
Let's imagine that we distinguish not cats and dogs. Let's imagine that we distinguish some time series, and we can understand that time series which we have in real life and which we pass to input. Do not looks like normal cat, or do not looks like normal time series as we have in our historical data. It is I think the main idea. We try to reconstruct. We do not try to categorize or predict cat or dog. We try to reconstruct if our reconstruction error is big, that we think that it's probably anomaly.
So you're working with not single transactions, right, but with time series. So a series of transactions is fraudulent.
Of course, after encoder architecture, we can apply for one event, but I think that more useful do it for some time series or for some trickly statistics for understanding that statistics of our process not usual.
Okay, thank you. And one more question from Osif. Are you aware of any good open data sets in this space for detection and payments?
Yes. No, it's not very good. It's as I mentioned, we have in financial data, we have problem that called sensitive data, and it's the reason why a lot of values may be missed when a company publish the data, or sometimes hashed. But nowadays we have, I think, we have some 5, maybe 10 data sets with anomalies, with financial anomalies and financial frauds. We have even one synthetic data set, and On last slide, I shared link to repository, and one of the file in this repository named dataset, and you can find there a lot of datasets that aimed to open financial fraud. That's all.
Okay, so you're going to have one more slide, right? That we have not seen already.
I think it's last slide context. I unfortunately yes. What Git repo? It is in this repo. I published slides and other materials related to fraud prevention, datasets and links to datasets, and I also publishing there another cases using artificial intelligence in finance.
Okay, thank you. Any more questions from the field? Then one question from my side regarding the two approaches. One is when we apply supervised learning and we have some partially maybe marked data set and we train on it and try to distinguish between fraudulent actions and normal. And the second approach is anomaly. Unsupervised learning, we try to search for anomalies. Intuitively, it looks like if you take pure anomaly detection, it will produce many false alerts. I mean, if you ask an officer to look at all these false alerts, he will be overwhelmed and will not be able to do anything. Do you have an idea how this problem is dealt with?
Yes, it is a big problem, but as I also mentioned, not all fraud black and white. We have some suspicious cases, and anomaly detection can track this events. It's first one. Second one, in our data, we very often have missed fraud or missed false positive and missed false negative. In this, if it's true, the anomaly detection algorithm also can help us to find a new feature or find something inside information. If you have a data set already prepared and there is no task to investigate some new cases, maybe anomaly detection algorithm is not so useful as in case when your data with noise or with missed cases. I think there is you can do some lab where you try to combine both this universe, supervised and unsupervised, and maybe there is some new idea. As I know, on Kaggle, for fraud detection for one bank competition, unsupervised learning use as after encoder use as something that generates new feature. This feature was a latent layer, not only the researcher use not only PCA transformation, but also uses some non-linear transformation that we have in autoencoder latent layer.
Okay, thank you. Any more questions? I think I have one more. Lots of them actually. Suppose you want to make a really simple anti-fraud systems. You have a small bank startup, if it's possible at all, and you really need to. You have 1 week of time, and you need to design something really simple. What is your idea? Suppose you have a data set. Part of a data set of transactions, and part of these transactions were reported by your clients as fraudulent. So this looks like a base for machine learning, for classification algorithms. So what do you do then? Do you apply, I don't know, random forest and that's all? Or my question is, do you somehow apply your understanding of fraud? This is not just any classification algorithm, but this is a fraud. Do you apply any specific knowledge from the financial field, or is it just a basic classification task for you?
I think it's if you say about some baseline, we can use a classical algorithm like logistic regression or random forest, and then analyze which features is more important, which is not, and it is enough. What it is necessary to dig deeper in domain.
But what is it? What is it to dig deeper? If you make this first attempt, and okay, you have a model which is forest, and it gives you, I don't know, 80% of accuracy, and then you want to make the next step. What it could be?
No, first one, we need to estimate financial losses. It's if we say about domain, we need to estimate financial losses, not how many in the count of fraud cases we catch. I think the second important thing that we need to estimate how many hackers, not transaction, we catch, and how many our good customers we deny the transaction. And also it's not about number of transactions, it's about number of people, of organization, amount of financial losses.
Mm-hmm. Okay, so you use different metrics.
Yes.
Mm-hmm. Okay, good. We've got another question here from Dmitry. Can anomaly detection help us detect transactions related to money laundering? So money laundering and fraud, is it the same or is it different?
It's all about money laundering. Of course, it's about not sometimes a part of about compliance, and maybe even risk management, but the most part of this case, it's about security and fraud. And of course, money laundering, it is a field where security analytics and security officers track or mining some new insight.
So money laundering is also part of this task that we've been discussing, right? So
yes, yes.
You can use more or less same approaches to detect.
I think there is on some slides, I think challenge number 2. It's about we have a lot of cases because there are a lot of interaction points. We have a list. 1 second. I try to find it. Anti-laundering, detection money laundering patterns. And for my opinion on it is about security and fraud.
Thank you. Any more questions? I think one last that I have, one slide intrigued me. You said that ensemble algorithm should not be used. Why?
Ensemble algorithm. What?
Ensemble.
Ensemble. No, I hear sample. Ensemble. Yes, it's because in financial sector we want to have understandable result or interpretable results. And sometimes it is a requirement from government. Sometimes it is ethics requirement. Sometimes we need understand a reason why we think that it is fraud or not fraud or something. Why we think that what solve model. It's important for human, for analytics, for men who decide or what should do.
So if you talk about classification task, then you should use something understandable. And if you if you talk about anomaly detection, there you can use anything like neural networks because they are absolutely ininterpretable.
There is in anomaly detection, we have a result, something, we have a big reconstruction error, or we have a cluster number 3, but then analytics need to understand why it is third cluster, not second, what it means in real life. Analytics need to decide, is it reconstruction error enough for say that it is anomaly or not. As briefly, you understand that after unsupervised learning models, we need a human intellect. But after supervised learning, there is no human intellect because model already said it is bad or good, white or black.
Good. Any more questions? I think mine are exhausted, and we've got 5 minutes to go if you want to add anything or any more questions arise. But more or less, we're done.
I shared my contacts. If someone have a question later, please feel free to contact with me and ask me a question. No problem.
Good. As far as I see, we have no more questions, and I think we're done for today. Thank you very much, Dimo.
Thank you too. Thank you all for joining.
Bye.
Have a good